Good morning class. Today we'll be starting network layer, which is a third layer in OSI model. As discussed earlier, in physical layer, which is the first layer of OSI model, we use physical address of a device, whether it is a computer, a connecting device. Physical address was enough to identify a device uniquely in one network. But when we talk about internetwork, that is internetworking, we require IP addresses. So today we'll be discussing what is IP addressing or logical addressing. IP address is basically a 32-bit of address which is uniquely and universally define a connection of a device. That device can be a computer or a router in an internet. What I mean in internet is that is a connection of various small network. It can be a connection of various LAN, MANs. Basically we use two versions of IP addresses, IPv4, IPv6. IPv4 consists of 32-bit of addresses. 32-bit of address means uniquely you have 2 की power 32 addresses. 2 की power 32 addresses can be uniquely identified, but as the need of more addresses arrived, this was not enough to uniquely identify devices. Then we shifted to IPv6, that is version 6, which consists of 128-bit of addresses. That means your address space has tremendously increased to 2 की power 128. IP addressing, or you also call it as internet addressing. Internet address consists of 4 bytes, that is 32-bit. 4 bytes means 1 byte consists of 8 bits. So 4 into 8, 32-bit. It is one and the same thing. As you can see here, this 32-bit of address is divided into two sections. One is net ID and other is host ID. What I mean by net ID is that you uniquely identify in which network your device is in. Suppose in an organization we have various networks, like one of the companies in Pune, one is in Delhi, one is in Mumbai. So you have different network which is required to be connected. So each network has a network ID, and then in that particular network you have different hosts attached, right? So in your 32-bit of address you have one net ID which identifies your which network it is. Then when your packet reaches that particular network, you can identify your host. In network ID only we subdivide that 1 bit or 2 bit or 3 bit depending on the classes. Later on we'll discuss that we have divided this address space into classes. You can identify in which class this address belongs to. Let's see what is classes. Suppose this is a 32-bit address, 88 bits I have divided into 4. That means 1 byte, 2nd byte, 3rd byte, 4th byte. You can notify your addresses in two types. Either it is binary, this is your binary representation, or decimal. You have converted this binary into decimal. This is 2 की power 0, 2 की power 1, 2, 3, 4, 5, 6, 7. 2 की power 7 is 128. It makes 128. In this way, you have converted this binary into decimal. So in two ways you can represent your IP addresses. Here is the conversion. You can see that these are the binary addresses. This question says that you need to convert this binary addresses into decimal. So what you are doing is 2 की power 0. This is 2 की power 7. 2 की power 0 is 1. 2 की power 7 is 128. 128 plus 1. This gives you 129. In this way, you are converting your binary into decimal. You can practice such questions. And now in this, you are converting a decimal notation into binary. So decimal can be converted into binary by dividing it by 2. Please practice these questions yourself. In this question, it says find any error if it is there in the IPv4. It gives you some of the notations which are being followed in IP addressing. In first, if you can identify, we have divided the address by 4 dots, that is 1 byte, 2nd byte, 3rd byte, then 4th byte, but 0 is not allowed in the leading place. 0 is not allowed. So this is the error. When you go to the second, only 4 numbers are there. 4 bytes makes one 32-bit of address, but in this there are more than 4. Here it is always less than 225. Why 255? Why 255? If all ones, that can be a maximum in 8-bit, that all are ones, that makes sum equal to 255. In this way, and binary and decimal cannot be a combination. Here comes what basically class we are doing here is, if there is a whole address space, a complete address space, 2 to power 32, that is some millions of addresses. We have divided that address space into 5 classes: class A, class B, class C, class D, and class E. How we have divided this into classes is, as I have told earlier, IP address consists of 4 bytes, first byte, second byte, third byte, and fourth byte. Depending on the classes, I have marked these as yellow. Yellow portion tells you the net ID, and the remaining portion tells you the host ID. That means if we are talking about class A, then the first byte, that are 8-bit, tells you the network, in which network it belongs, and the other 24 bits tell you, remaining 24 bit tell you which is the host number. That means the networks which belongs to class A, they have, each network can have many hosts in it, because 2 to power 24. When you comes to class B, 8 plus 8, 16 bits are used to identify the network. Remaining 16 bits tell you the host ID. That means in class B networks, you can have maximum 2 to power 16 hosts in one network. Means class A has larger networks, class B networks are smaller, class C are much smaller, because only 2 to power 8, maximum 2 to power 8 hosts can be there in one network. Is it clear? Then class D, then class E. Class D is used for multicasting purpose. Multicasting means a message is sent to multiple classes together, multiple hosts together. Class E is reserved for future uses. What these number tells you, class, is that if the address in binary notation starts with first bit is 0, that means you automatically know that this is a class A address. If the first bit is 1 and the second bit is 0, you can easily identify it as it belongs to class B. If it is 1, second is 1, and third is 0, it is class C. Triple 1 and 0 is class D. All ones are class E. Similarly, in decimal notation, we can identify that if the first byte, that means number before first dot, is from in the range from 0 to 127, it belongs to class A. If it is from 128 to 191, it belongs to class B. If 192 to 223, class C. 224 to 239, class D. 242 to 55, class E. How? Let's see with an example that you can easily identify your address. For example, in this question, this is saying find the class each address belongs to. If this is a binary notation, I told you if the first bit is 0, you can automatically classify it as class A. Now, when you come to the second part, first bit is 1. You don't know which class it belongs to. If the second bit is 1 and then third bit is 0, it belongs to class C. You can see in this previous image, if first bit is 1, you see the second. Second is 1, you see the third. Now it is 0. You know that it belongs to class C, right? Now when you come to this is your decimal notation. 3 dot, that means 4 bytes. If it is 14th, first byte is 14th, it belongs to the range 0 to 127. So automatically this belongs to class A. Now it comes 252. 252, you can see here that the range lies here, 252. That means this belongs to class E, right? In this way you can categorize which address belongs to which class, right? Here it is given that which I have told you that class D is for multicast, class A B, C is for unicast, that is one-to-one transmission. Class E is reserved for future use. Number of blocks tell you that how many unique networks can be there. As I have told you earlier, in class A, first byte was used for net ID, that means 2 to the power 8, that is 128 network can be there, and each block size is this is 2 to the power 24. In class B, it is 2 to the power 16, 2 to the power 24. In this way, you get to know what is the size of the block and how many blocks can be there. What the problem basically arises in classful addressing, that you're dividing this complete address space, this block, into classes. Suppose if we talk about class A, you have one network, like we are creating a network for VIPs. VIPs is an organization. You have taken an address for class A. You don't have that many requirement for the host 2 to the power 24, so we are wasting number of hosts in VIPs. So basically available address space was waste. If you go for class B and C, they are being used, more likely to be used for medium organization. In medium organization, but as the requirement keep on growing, the address space depleted. Therefore, we have shifted to classless addressing. That means you are not dividing your your address space into classes, but we don't need to go in detail in classless addressing. That is not in our course. What we'll further do is subnetting. Many a time question comes, what is subnetting and what is supernetting? Subnetting means that you are dividing your bigger network into smaller. As I have told you in the previous example, if you are having a address for class A, you have lots of hosts, but VIPs is wasting those hosts. You don't have that many users or that many students in the organization. You can subdivide it into network, and that subnetwork can be used by a different organization. In this way, you are doing subnetting. What is supernetting? That you're combining small networks into big networks. As all A were used, now B and C are available. C has a very small block size. You can combine them together to make an organization with more addresses, right? This I have already told you that we are shifting to classless addressing. We'll further continue this in our next video, as I have a time limit of maximum 15 minute video can be uploaded.